Guys, today's topic for the presentation video is we will be discussing about logic design and the different Boolean laws. To start with, first I would like to give you a brief difference between the SOP and POS. So, what is an SOP? SOP. So you can write that as SOP. What actually an SOP is? Sum of product form and product of sum. We'll be differentiating between the SOP and POS. Okay, I hope it is clear. SOP is basically the sum of product form, the sum of product terms. So when we say SOP, this SOP means sum of product, and product is POS is product of some form. Okay, so this is the basic difference between SOP and POS. To start up with the topic, what topic we are going to read is basically the topic is Boolean algebra and we will be doing today some of the Boolean laws and what are Boolean laws, logic, symbol, this we are going to do today. That what is a logic circle assignment. So I hope it is clear to all of you that how we differentiate between SOP and POS. So let me tell you again one difference between SOP. Just showing you an expression. How do we write an expression? So we do write it like this way. Now suppose I write x y plus x bar y. So here you can notice there is a plus sign in between the two product terms. So here we can say that this is sum of what? Sum of product terms. This is my product term. Sum of product terms. Terms we are saying, so this is my term 1, this is my 2, it might be possible that we can extend it to any other value, x bar y, then it becomes my third term. Okay, so we can say that sum of product term is, this is known as sum of product terms. Product terms is what? X and y is a product term, and any SOP expression can contain n number of terms. Now moving to POS, similarly we can write it for POS also, that how do we define any POS expression. Let me explain you the POS expression. In POS expression, we say that suppose any any variable you want to write. So we are writing x plus y, the plus sign between two variables. X plus y multiplied by x bar plus y. Now, can you see the difference between the term which I had done earlier, x, y plus x bar y. So, here we were discussing about the sum of product terms. Here you can see the the product of sum term. Can you see this? This is the plus, this is the plus. So here we are trying to say this is my POS, this is my SOP. So this is the basic difference between SOP and POS. Now moving ahead to the truth table of SOP, what is min term, what is principle of duality. So let's discuss it a little faster. So in SOP, the terms which you are taking. Now, suppose if you have taken a now let's try and make any truth table. And if you try to make any truth table, so you will make out that uh, let's try and make a truth table x, y. Okay, and you are writing it as 0, 0, 0, 1, 1, 0, 1. So here you are having two variables, you have four combinations possible. So what does it do? So remember in SOP, the sum of product form, we are using the min terms. The min terms. What is a, this is total min terms in SOP. So when we do the summation of these min terms, so suppose this is my first min term M0. I can write it as M0 as. Now herein 0 represents no value, 1 represents high value. It does means that 0 is a positive. We are saying no means 0 will represent, of course, the x bar, and 1, this represent x bar, and this represent y or x. You can take it anyway, कोई भी वेरिएबल है. अगर आप 1 देखते हैं तो x आएगा, 0 देखते हैं तो x bar आएगा. So this will be, and it will be in a form of sum of product terms. So you can see this is now let's take one more variable first, then we would be able to understand it more clearly. So let me extend this further more variables x bar y. This example we have taken. We will try to make a income table. I have already cleared with, I have cleared in, so this will be x y plus, हमें इस एक्सप्रेशन पे पहुंचना है सपोज. ठीक है, तो इन दोनों का टर्म जो हमारी वैल्यू है, ठीक है, हम इनकी मिन टर्म को ऐसा लिखेंगे. फाइनल फंक्शन अगर मुझे ये लिखना है, अगर मान लीजिए मैं इसको हटा दूंगी, मैं फाइनल फंक्शन ही आपको लिख के दिखाऊंगी. फाइनल फंक्शन वैल्यू विल बी, this will be x bar y bar. Okay, this is x bar y bar. Then this is x bar y. So this is my first midterm m0. This is my second midterm m1. This will be my x y bar. This will be m2 x y. Okay, so this is one function. These are my midterms. When I add all these terms, I simply add all these terms. M0 plus, M1 plus, M2 plus, it becomes my SOP. This is my SOP. This is my midterm 1, midterm 2. So we will say M0, midterm 1, midterm 2, midterm 3, midterm 4. So I hope it is clear with you all that what is a midterm and a max term. Now moving for next term, and how would you write this expression as? So this will becomes x bar y bar plus x bar y plus x y bar plus x y. So this expression is basically the sum of product form, sum of product terms or sum term. So these are my min terms. These are added. This becomes a SOP. Similarly, looking for max term, and in min term, you remember 0 represents the low value. That means it is a x bar. It is a complement value. And in POS, it becomes just reverse. So, table, POS as well. So here 1, 0, 1. So here we are trying to write now. POS expression says POS expression says in POS we are using the max term. So 0 represents your x value and y represents your, or you can say 1 will be represented by x bar. Here 0 will be represented as x as a positive number and this is represented as x bar. Now 0, 0 means it is a high value. That means x y. This will be x y bar. This will be 1 is x bar. What is y? 0 is what? Positive value. You can say x bar. You see the difference? Here 0 tends to x. If you are writing in POS expression, 0 means x, 1 means x bar. If you are writing SOP expression, 0 means complement value x bar and 1 means the x value. So we always try to write an SOP expression. आपने हमेशा देखा होगा function SOP की form में लिखा जाता है जिसमें 0 हमारा हमेशा x bar रहता है. Easy to understand. Now here this will tell you that yes, this is my max term. So this is my first max term. So this is known as in POS. Each individual term is a max term. If we are just going to add up these max terms, we get an expression as x plus y product x y x plus y bar product term x bar plus y and finally x bar plus y. So this becomes my POS expression. I hope it is clear the POS expression in term and all. Now moving to another important thing, what is principle of duality, and after that we'll be doing some circuit designing. And if you want more circuit designing, let me know in the comment section box, where I'll try to show you one. Just hold on. So, principle of duality. Now, principle of duality means when you are converting 0, when you are converting 0 to 1, 1 to 0, plus to dot, and dot to plus. Remember this. This is my principle. This is my principle of duality. Okay. So, this is known as principle of, this is principle of duality. So if we are having x plus y, okay, x plus y bar. What we are going to do? X means here it is a positive. This is a sum of products form. You can see this is a midterm. And in SOP we know x represents 1 and bar represents 0. And principle of duality says converting zeros to 1 comes to 0. So this is my x, so I converted to x bar. This is y bar, I'll convert it to y, and this plus sign will be converted to dot and it will become y. So, after applying principle of duality rule onto this expression, my expression becomes this expression. Simply converting zeros to 1, 1 to 0, plus to dot, dot to plus is my principle of duality. Now, moving ahead to different Boolean laws, I'll just explain you a little faster whatever different laws. Now, midterm is clear to all of you. I hope so. Now, we all know the mathematics law of associative law, which says A plus B plus C. This is similar as we do in mathematics. It associates. Associates means either you put a bracket before or after, we get the same. By writing here 2 plus 3 plus 5. So here you will be adding 3 plus 5 plus 2, 7. Here you are adding 2 plus 3 plus 5, whatever value you have taken. So when it goes to 2, 3, okay. So here we are adding 2 plus 3 first plus 1, 6. Here I am taking the value as 1 plus 2. I am adding the 1 plus 2 value first. This is I am associating the value. That means I will be getting 3 plus 3. So can you see the difference? Yes, I am adding here 3 plus 3, but the law is same, the value is same. Okay. And associative law applies on multiplication also. If I convert it to multiply sign, suppose both ways, then also it becomes the same. So 1 into 2 into 3. 3 to the 6. 6 into 1 is 6. So in rough form by chance, it will be giving the same. So here 1 into 2 into 3. It will again give you 6 into 2. So this is how my associative law works. Now distributive, it distributes the value. Okay. Now how does it distributes? I will show you. A plus B, A plus BC. Okay. This will distribute. That means A is being added to B also. A is added to C also. So we distribute it. A plus B and A plus C. We can convert it to multiply also because both distributive and associative law works on multiplication as well as on. So please don't get confused. This is my plus. Again, I haven't included my plus. A plus B will over A plus C. Okay, we have distributed the value. So this becomes my A plus B, A plus C. So this is my which law? This is my distributive law. Now moving ahead, there are n number of laws. There is an annulant law. In annulant law, it's also known as some different laws के नाम से भी आप देखेंगे उसके अंदर. So we have A dot 0 will give you 0. We have A plus 1 will give you 1. Okay, so if we have a into 0, we get 0, a plus 1, we get 1. The identity law is also there. A dot 1 is equals to a. Or if we are writing a plus 0, we are getting a. Either if we are using plus with 0, we get a. Either we are using dot 1 is equals to a. So these are another laws. Moving ahead, let me tell you the item quotient law also. It's again very easy. We simply says that a plus a will always give you a, and a dot a will also give you a. This is very important. To minimize an expression using Boolean laws, we use these laws and try to minimize the expression. The first way is using K-map, but another way, either you can simplify an expression using a K-map or a Boolean law. So A plus A will give you A. That means 1 plus 1 will always give you 1, or 1 dot 1 also will give you 1. Okay, 0 plus 0 is 0, 0 dot 0 is 0. If the input, either the input can be 1 or 0. Now moving ahead to the complement law, again it's very important law, and many times we used to use this complement law as well. So complement says we always get a 1 if we just add one complemented value to a normal variable. A plus A bar gives you 1, and A dot A bar gives you 0. Very, very important. This is a complement of A plus A bar gives you 1, and A dot A bar gives you 0. Okay. There is another law which is also known as double negation. Double negation means a bar of a bar. A bar, again a bar. So you complement one value and again complement that value, that will give you A. So this is a double negation bar. There is another law, absorption law. In absorption law, the variables get absorbed. So A dot A plus B will give you in absorption law. You will only get A here. So this is my absorption law. Then A plus, and we just convert the sign, A plus AB. A plus, can you see this? We have done nothing but A plus, we have converted the sign, dot की जगह plus आ गया, plus की जगह dot आ गया. And this A dot, these are also used in your different real simplification as well. So then moving on to very very important law and the last law, that is the De Morgan's law, and I'll tell you how to design a circuit right now. Okay, I have already told you how to make a min-term maximum table. If you want some examples on three variable min-terms, let me know in the comment section box. I will make that also. De Morgan's law, I have told you also x bar y plus x y bar. This is one law. Now converting the sign, x bar, sorry, yeah, first one is correct. Then x plus, so what we are saying, x plus y bar dot x bar plus y. These both are the moments. Can you see that x bar y plus x y bar or x plus y bar dot x bar plus y? These both are known as De Morgan's law. Okay. Now I'll move to one circuit designing faster for you all, that how do we design. Suppose we are having two variables, then how we are going to make the logic. Now suppose x bar y bar plus x y plus x bar y. Let's make a logic circuit of this. X bar. So we have two variables. So this is x bar means a NOT gate. Y bar means again a NOT gate, and both of them are connected with a AND gate. Not an OR gate but a, so this will give you a term of x bar y bar. Okay. The next term is x bar. So I just connected from here only. I'm not going to write down again. So x, y. Again they are connected with a AND gate. This gives me the expression of x, y. Then x bar. If you can see x bar. So here is a position of x. Then here is a position of x bar. So I'll connect the circuit from this side. X bar. Okay, can you see how I have connected x bar, and y is very simple. So y, we make an AND gate, we get an output as x bar y, x bar y, and all of these gates are further connected to a plus sign. That means all three of them are connected with the OR gate. I simply complete this circuit by just connecting the OR gate, and now finally it will give me expression. Or so this is how we design a logic circuit. I hope it is clear to every one of you. Now this is a two variable designing, and if suppose we are having a three variable, then also we are going to do in the same way. The truth table we take combinations, eight combinations, and so the combinations are like this: 0, 0, 0, 0, 0, 0, 0, 1. Then 1, 10, 11, 100, 100, 10, 11. So just to conclude, I'll tell you that a three variable map will work like x, y bar, z plus x bar, y, z. Suppose I want to make a logic circuit for this. So x, I'm just quickly making it, y bar, z. So they all are connected to a AND gate. They are connected to an AND gate. Then x bar. So what is x bar? I have to make an x bar. This is my x. I have to make it x bar. वहाँ पे x bar already था, यहाँ मुझे बनाना है x bar. तो मैंने x bar. This is my This is my X, this is my Y, this is my Z, then this is my Y, this is my Z. Okay. So all this is connected to an AND gate and further they are connected with a OR gate. Okay. So further they are connected with the OR gate. So we will be making this OR gate. How it works. OR gate. So we get this circle of a three variable. When you make a truth table, there will be three variables. So we will have eight combinations. So here in this lecture, we have discussed about the SOP, sum of product form. It takes min terms, POS, product of sum form. It takes max term. We have discussed about principle of duality, and then we have discussed about various laws which helps in simplifying some expressions, and finally making some circuit diagrams. If you're interested in knowing more about these circuit diagrams, how we make, you just mention in the comment section box. I will make more videos of that. That's all for today. Thank you so much.